In this exercise, we're going to discuss placing components in an assembly. In Inventor, the main reason you use an assembly file is the ability to interchange parts and use those parts in other assemblies. What this means in the simplest form is, if I come in here and I right click on this and I say component, say replace, I can now go into my design robot file and I could find a separate base, maybe a different model. Maybe this customer A wanted a 100mm base and customer B wants a 150. Say yes, and you can see there, everything completely stayed the same with the exception of this base got taller and everything moved in relationship to that base. And it's true with any part on this assembly. If I want to exchange it out, all I have to do is select it and say component replace. Now, as far as the different types of files in Inventor, you can place almost anything. Start with the place command. We can place from Vault, if you have a Vault. You can place from iLogic, which is kind of a little bit more advanced topic that allows you to create a part on the fly. We can place from Content Center. There's literally hundreds of thousands of parts in Content Center preloaded for you. This is your nuts and bolts and washers and fittings and pipes and angles and pretty much anything you can think of is in there. And then we can just use the regular place command. So if you want to follow along, let's go up and let's open designrobot.iam. When you open it up, kind of zoom out here so we can see it. You'll have one part in there already. So that's our base part that was preloaded. And we're going to say place. Now we could drill down in here and I could say go into chapter 6, go into the design robot, and you could hit insert, okay, with all of these different parts. Or what you can do is you can hold down control and get all the parts except for the bases, because we already have a base in there, and just hit open. Inventor will give them to you. If you need more than one copy, you can drop them in there twice. They'll give you 2 copies of everything. So on and so forth until you get all the copies made. You also have the option of going in here, just say open in the new window here. And I can literally just open up Windows File Explorer, grab a couple parts here, just drag them into my assembly. I click back over to Inventor, you can see it just dropped them in there for me. So I have a couple different ways there of dropping in parts into Inventor. If I come up here to place, I wanted to look at a couple other things. By default, it gives me all the IPT and IAM. These are all the parts we're going to create, the Inventor parts and assembly files. But I have a bunch more options. I can do alias files. I can do DWG files. I can do files from Inventor Fusion. We've got CATIA, got DWF and DXFs, IDFs, IGES files, JT, which is your old Unigraphics, NX, I think is the new Unigraphics, Parasolids for binary and text. We got ProE, which is now called Creo. You can see now they're called Creo parametric files. Rhino, which is a SolidWorks product for doing analysis. SAT files, STEP files, STL files, SolidWorks files, and basically all files, of course. Some of the ones to take note of, SAT file is the ANSI kernel that Autodesk products are built on. So if you ever have a problem getting a DWG to open up correctly in Inventor as a 3D model, save it out as a .sat file, and you'll get a good clean solid model from AutoCAD. Just a little workaround there. Next is the IGES files. IGES are the oldest of all the generic file types. This is like a consortium of companies went together and wrote this way, way back. This was originally intended for 2D drawings, and it's a 2D standard. A lot of your mold makers still use this as a standard, so if you're ever asked to send something to China, it may be in an IGES format. STEP. STEP is probably the cleanest form to send things back and forth between like SolidWorks and ProE and things like that. You can get direct SolidWorks files or direct ProE files, or they can save out to Inventor files. Sometimes that works, sometimes it doesn't. So STEP is kind of the universal 3D file format. If you save it out as a STEP or you import it in as a STEP, it's a really good way to get files into Inventor. I've also seen issues if you bring in a CATIA or a UG file, for example. Sometimes what'll happen there, if it's a sheet metal part, there's not enough gap in between the parts. It wants to use the exact same face. And so Inventor says, whoa, 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 that's physically impossible. You can't do that. These guys are breaking the laws of physics when they unfold their models. And so sometimes if you do bring in a file from one of those guys, you'll actually have to go down and like rip a sheet metal part so that you can get it apart. But for the most part, you can import in any file you want into Inventor. Once you drop it in, you would start the constraining process. The first part that you drop into your model is going to be grounded. What does that mean? It means I can move these around anywhere I want, except for this part. The reason I can't move it around is because it's grounded. If I unground that, I can then move it around. And the reason it's grounded, let's take a look at this finished robot. If I grab this, I can move this robot around, but you can see it does the funky chicken on me. Because there's so many joints, Inventor doesn't really understand what you're wanting to do. One of the tricks there is to grab it kind of near the joint you want it to move. Sometimes that'll kind of help it out a little bit. But if this was not grounded at all, and I started moving it around, it would really do the funky chicken. I mean, this will make some people car sick, it's so bad. So instead what you do is your very first part by default is grounded. And if you have to delete your first part or move it or something, ground it again. Another little trick here is if you take, say, this part here, get it kind of where I want it, and I ground it, then I can move the other little bits and pieces that I want. You can kind of move stuff around a little bit easier once that part's grounded. Get the next part where I want it to be. So I can ground this one. So now it's a little bit easier to move and get what I want it to do. So that's what the grounding does. It allows you to lock things down. So what I want you to do is open up this robot in any way you want. You can either go to Place Component, or you can go out to Windows File Explorer and open up a window and drag these parts in. Go ahead and drag in part 1, 2, 3, 4, 5, and 5 adapter, and clamp mount. Basically everything but the base, and drop these in here. Play around with them a little bit. See how you can rearrange them. Get used to rotating around your different directions using your view cube or holding down F4. Remember, that'll allow you to move around if you hold down F4. If you're lucky enough to have a 3D controller, practice with it a little bit. I do not make money off of this anymore. At one time I did sell these because I am a firm believer in 3D controllers. As you get more and more complexity in Inventor, the more and more you need it. So as we get into assemblies, it becomes more and more important to be able to move and look around things. So if you don't have a 3D controller, get used to the view cube and get used to the hotkeys and the shortcut keys for rotating around. The biggest thing I get on my students about is not rotating a part around. Don't try to do it all from one view. If you watch me work, you see I'm constantly looking at different views because I can't see in every direction. If I'm looking at it flat, I can't see, am I moving it in XY or am I moving it in Z as well? So if I rotate it around, I can see which axes I'm moving it and which directions I'm constraining its degrees of freedom. So play with this a little bit, move them around, just look at them, drag them around, see what you like. And if you want to even get creative and try to assemble a couple of them, feel free to. We're going to do that later on in another exercise, but play with this a little bit and see what you can do.